few classes we have already covered up the few topics of the motion, and I know that you people were waiting for me to start with the next topic, that is being the distance time graphs. So what is a distance time graph, what we can calculate from this? So we are going to learn the distance time graph in today's class. So let's just move ahead. Okay, so in this class, what we are going to analyze, the distance time graphs. We'll be understanding the detailed explanation of the constant speed. Then we'll be talking about the analyzing the changing speeds, and then we'll move to the most important part of the graphs or of the physics, that is the calculations, the numericals, the questions. Okay, let's just start with the distance time graphs. When I talk about the distance time graphs, so here you are plotting a graph over a axis, two axes, x-axis and y-axis. Over the x-axis, you are going to plot time, which is an independent variable. It is an independent variable. Okay, and on the y-axis, you are plotting the distance, which is a dependent variable. Which is a dependent variable. Okay, understood? Now, what I can get from this graph and why I am drawing the graph. So the importance of this graph, that it helps you visualize the motion, whether it is moving at a constant speed or it is a varying speed or the object is at rest. Okay, now before we move further, to understand from a graph you can calculate two things. One is the gradient and another one is the area under the curve. In this class, first of all, I'll let you know how you calculate the gradient. For an example, suppose this is a straight line which we have drawn on this graph. How do you talk about the gradient? Gradient is always the change in the y divided by the change in the x, or you could talk it as rise over run. Okay, when I talk about the rise over run, you just choose one point. What is the run towards the point? So this is the run. Okay, and then you have to rise to reach that point, so that is the rise. Okay, so when you are running, you are covering the time, so the time interval, so the time interval. Okay, and when you are rising to that point, then you are covering the distance. Okay, so let's just say the distance. Okay, so here you have delta x divided by delta t. Delta x is representing the change here, the distance, and delta t is representing the time interval. So what is distance divided by time? If you remember the speed, so it is being given as speed. Okay, so what we can have from the distance time graph, that will calculate its gradient and we will get speed from it. So this is an important point which you need to remember, that from the distance time graph you will get the speed. Let's just move ahead. So here we'll start from the thing that is being called as rest. What is the distance time graph of an object which is at rest looks like? So here if I talk about distance and time, it would be a straight line. So what is a straight line which is parallel to the time axis means that the object is at rest. Okay, it is not even moving. With the passing time, its distance is same. Okay, so that is being as rest. And there is a one query, and that is, what is the gradient of a parallel line or of a straight line? It is better to mention it as, what is the gradient of a straight line? Yes, you guessed it right. It is 0. Okay, because it's a straight line. When I am talking about the straight line which is parallel to the x-axis. Okay, it is parallel to x-axis I am talking about, or parallel to y-axis I could talk about. Okay, any lines, this line, these are straight. They are like as their gradient, their slope is 0. But if you look at this graph, its gradient is not 0. This one, this straight line and this straight line, these are different from each other. It is at a certain angle with respect to the x-axis or the y-axis. So it means it is a straight line, but it is a slanted one. Okay, So when you go with this kind of a graph, what does this means? That with the time, the distance is increasing. And what does the straight line means? That it is a linear increase in distance with time. Okay. So what does the gradient here means? The gradient will gives you a speed, and because it is a slant line giving you a constant value, and therefore it would have a constant speed. So the gradient here will gives you the speed, and this kind of the graph shows you that the object is moving in a straight line with a constant speed. But it's not necessarily that every time an object moves with a constant speed. You might encounter these kind of curves where the distance is being this way or it is being covered as this way. Okay, so if I have a distance time graph of this kind, how do I know whether the object is being moving at a constant velocity or a constant speed or varying velocity? So you just choose different points and draw the gradients over it. Okay, these lines which are touching. Is the gradient increasing or decreasing? You see the slant is being going to increase. So it means the gradient increases, correct? And when I have a distance time graph of this kind, how I know whether it is been moving with the same speed or what? So what I do, I'll draw the gradients. Now just look at the gradients. What is happening? It was this, the slope. It has been decreasing. So here the gradient is decreasing means the speed is decreasing. So these motions are being like of increasing speed here. Okay, and here it is a decreasing speed. Okay, I hope I'm clear that what does a gradient mean and how would you find out whether the speed is increasing or decreasing. Okay, let's just talk about the constant speed now. Here already discussed that your gradient will gives you the speed. Now the thing is, if I talk about two lines or the distance time graph, here I have two lines. Which one is being more steeper? This is more steeper, so it would have more gradient. Okay, so when it has more gradient means it would have more speed or high speed, whereas the shallower slope or the gradient means lower speed. So do understand that the straight line representation means that this motion is a constant motion. Constant motion means uniform motion, correct, where there is no acceleration or deceleration. Okay, and when you talk about the slope magnitude, the steeper the slope, here do remember slope here I am referring as gradient. Okay, and steeper the slope, the greater is the speed of the object moving, correct. Now already discussed about the stationary objects, it's a straight line. So for an example, a person who's been standing at the bus stop, okay, its position is not changing over the time, so graph will represent a horizontal line. Let's just talk about the changing speeds. Again, here the decreasing slope, correct, and here is the increasing slope or increasing gradient. So increasing slope means increasing speed, decreasing slope or gradient means decreasing speed. Okay, now the next thing is being how would you calculate the speed from the graph. For an example, here we have a cyclist who travels along a straight path. The distance time graph shows that the cyclist cover a distance of 50 meters in 10 seconds. How does the graph of this straight line looks alike? Here you have distance and time. So the distance is 50 meters somewhere here, I'm assuming, and it in 10 seconds. So you just got 2 points and you just chosen 2 points and to draw a straight line. Now, how would you calculate the speed? See, there are two ways. Either you directly use the formula, but when we are focused on the graph, then what we'll do, we'll calculate the gradient. So I have the gradient to calculate, that is rise over run. Correct? So how much we have to rise to reach this distance? This is my rise, so that is around 50 meters. And here, what is the run? Run is around 10 seconds. So I get my answer as 5 meters per second. So the cyclist's speed is 5 meters per second. I hope you got an idea about the distance time graph, what we can calculate from the distance time graph. If you still have any doubt, please do drop your queries in the comment section. And if you like me to bring more questions on the graphs, please do drop a comment. Okay, thank you and have a nice day.